Okay, everybody, welcome back to book 4. So today, a fan has sent us this question. By considering the unit circle, state whether the following are true or false. Okay, so what this question is about is comparing the values of sine, cos, and tan, less algebraically, but more so through looking at the unit circle and thinking about how these angles work. Okay, if you remember from last episode, the values for sine, cos, and theta, for sine, cos, and tan, I should say, correlate to the triangle formed on the unit circle. Right, for example, let's look at question A. Okay, question A here. So sine 10 degrees, and we're comparing that to cos 10 degrees. Okay, so let's see, sine 10 and cos 10. So let's form the angle first, 10 degrees. So that's going to be about here, right? There we go. Okay, so that's 10 degrees. Very nice. All right, 10 degrees. Now, if we come up to here where it touches the circle, right? We can draw down this way. I'll use a different color actually. We'll draw down this way. And at the same time, we can draw across, right? Because that completes the base of the triangle. So we have the height and the base of the triangle. Okay, let's see if you guys remember what this bit here is called. It is the hypotenuse. Very good. All right, so we have the height and the base. Now, this is where sine and cos come in because the length of this base, right, given that the radius of the circle is one unit, in that case, the length of the base is going to be cos theta units. Okay, very important. This is how we define theta. That's just how we define cos and sine. Okay, likewise, on the top here, for the height, it's going to be sine theta units. Okay, you probably remember that sine is the y-axis, cos is the x-axis. That's what it means here. Now, if you have a look at this triangle, I mean, it's quite clear that at 10 degrees, we're going to have this relation, right? So sine 10 degrees is clearly going to be less than cos 10 degrees. All right. All good with that? Let's have a look at a second example, right? We'll go to the next question. Cos 80 is greater than sine 80. We'll do the same thing. 80 degrees. All right, if you think back to your quadrants, 80 degrees is going to stay in the first quadrant and it's going to be here, right? So this is 80 here, right? And just for completion's sake, this here is going to be 10 degrees. So what's happening is you actually just have the same triangle as here. Instead, it's like flipped up to the y-axis. Anyways, now we have this 80 degrees here, and we can again form a triangle, right? So this is the base here, and this is going to be the height. The height is here, right? Let's have a look at it again. Height, sine theta, sine 80 specifically, and the base, cos 80. Okay, we can see that clearly. The base is shorter than the height, so cos 80 is going to be less than sine 80. Right? And a trend you notice, right, is here, try to do this exercise. You start with 0 degrees, right? 0 degrees is going to be here. Then you gradually move it up, move up the hypotenuse, right? And you can form different triangles. What you realize is the base gets shorter and shorter as you approach 90 degrees. And that's actually how this works, right? If you graph the function of cos, what you're going to get is it's going to start at its highest point, and then as it approaches 90, this is cos theta, as it approaches 90, the value is going to gradually come down to 0. Okay. Now, you would probably know that once it goes past 90, right, we would come back the other way, right? If we're here, we're going to come back the other way. We'll be at this point here. Okay. So then, as the angle keeps increasing, right, the triangle goes lower and lower, and because of that, cos theta is going to increase in size again, except in the other direction. So it's going to become negative, like that. Okay. until 180 degrees. So just a little fun fact on why the graph of cos theta looks like this, right? And then you can continue, right, using the same logic. Continue, and this is how you complete the graph. All right. We may or may not use this later. We'll see. Now, next question. Let's pick this one. The question says, sine 50 degrees is less than tan 50 degrees. Let's figure out how we can do this. Let's go to the next set of axes. So sine 50 is less than tan 50. Is that correct? Well, let's see where sine 50 is, right? So this is 45 degrees. It's going to be smack bang in the middle. So sine 50 is going to be just slightly higher, like here, right? So that's 50 degrees. Okay, so we're going to have this is sine theta here, sine theta, and this here is going to be cos theta. Now, could you recall what the definition of tan theta is? Tan theta, or in this case tan 50, is going to be the same as sine over cos, right? It's always sine over cos. Sine 50 over cos 50 degrees. Now, let's have a look at what we're comparing. We're comparing sine 50 and tan 50, right? Where's sine 50? Sine 50 is right here. Cool. What about cos 50? What about tan 50? Tan 50 is going to be this red length divided by the length of the base, right? Because remember, cos is going to be on the base. Always the base of the triangle. Well, what do you notice? This here, this is 1, right? The circle has a radius of 1. So cos theta, cos 50 is going to be less than 1. And when you divide something by something that's less than 1, you'll get something bigger. Okay, so this here, sine 50 divided by cos 50 has to be bigger than sine 50. Right? Right? You can think of it this way. If sine 50 was, let's say, 0.7, and cos 50 was 0.2, right? Then what's going to happen? Let's say 0.3, just, doesn't matter. So what's going to happen, right? Sine theta divided by cos theta, which is tan theta, is going to give you a value that's going to be bigger than what sine theta is, right? Because cos theta is less than 1. So is sine 50 less than cos tan 50? Yes, it is. Very good. Okay. So far we've been dealing with the first quadrant, right? Let's move on to the other quadrants. Let's go back here. Let's choose the last question, okay? Why don't we do this? Question J, right? So cos 50 is less than sine 50. Okay, cos 50 is less than sine 50. Sorry, I should say cos 350 is less than sine 50. I will ask my editor to cut that bit out. Sine 85. All right. Sine 85 degrees. Okay, please let me know in the comments if that bit wasn't cut out. I'll have a talk with my editor. Okay, so what we have here, right? Cos 350, we have two angles. Where's 350? So, as we keep going anti-clockwise, our angle is going to grow bigger and bigger. So sine 350, sorry, cos 350, I should say, is going to be in the fourth quadrant, and it's going to be just 10 degrees away from completing the circle, right? So this bit here is going to be 10 degrees, and everything here is going to be 350. Okay, we can't really make a triangle with 350 degrees, so we'll just choose the other bit. It's going to be this bit here, which is going to be 10 degrees. Okay, 10 degrees. So let's again complete the triangle. This is here. So cos 350 is going to be, right? It's going to be this space here. This space here is cos 350. Cool. Now let's see where sine 85 is. Okay. So 85 is going to be in the first quadrant, and it's going to be 5 degrees away from the y-axis. So this is going to be sine 85. Right, sine 85. like that. Okay. So even at this point, it's still a little bit difficult, right, to see what's going on because we're comparing the base here versus the height here. What we can do, right, is for sine 850, sine 85, we can rewrite it in a very smart way. Instead of drawing the triangle this way, right, this way we're going to have sine 85, fair enough. Why don't we draw it this way? This will be 5 degrees, right? And we can draw this triangle here. And you'll see why this is so much better, right? So for this triangle, right, remember what we said, sine 85 was going to be the height, okay? And what you see is the height for this triangle is going to be the base for the smaller triangle, right? They form a rectangle, okay? So this here is going to be sine 85 degrees. So what we're comparing is this base here versus this base here, okay? I'll draw the two triangles out for you. So that's going to be, that's going to be here, 10, compared to this, okay? Going to be 5, okay? And we're comparing the bases. This is cos 3, this is sine 85, I should say. 5 degrees, sine 85, and this here is cos 350, okay? And what we see, right, remember what we said before, for the base of the triangle, as your angle gets bigger, right, the bigger your angle gets, the more sort of anti-clockwise it goes, right? As your angle gets bigger, your base is going to get shorter, okay? So just ignore, if you just ignore these designations, right, we'll just look at the triangles. Clearly, you can see the base of the 5 degrees triangle is going to be larger than the base of the 10-degree triangle if we correct for the hypotenuse, right? And we know that the base of these two triangles are represented by these two expressions. So from here, we can say that sine 85 degrees will have to be greater than cos 350, right? Now, if this is a little bit confusing, we can rewrite it in a different way, okay? And I don't know if you guys have come across this, but basically what you can have is a sine theta. You can rewrite this in terms of cos, with cos 90 minus theta, okay? Vice versa, cos theta is equal to sine 90 minus theta. Okay, so let's do this question with this method, right? What we can do is we can rewrite everything in the same form. So what we're going to get is, we're going to rewrite, let's rewrite sine 85, okay? So that's going to be cos 350 degrees is less than cos of 5 degrees, okay? So we go back to what we were talking about before. Cos 350 represents this triangle here, right? 350, because the remaining angle is going to be 10. So that's the triangle that's being formed. Once you go around this revolution, this is 350, and what is remaining is 10. We're comparing this with cos 5 degrees. Okay, so this triangle here. Right, so this base here can be represented as sine 85 or cos 5 degrees. Right? So same principle as before. As the angle gets bigger, the base of the triangle is going to get smaller. Right, so therefore, we're going to have cos 350 is going to be less than cos 5 degrees. Because this triangle here has a larger angle, therefore it has a shorter base. All right, so try the same with the rest of the questions. Okay, whenever you see tan, just change that into sine over cos, and that'll make things easier. Okay, and just one last thing is, for this question, you come across triangle angles in the second, third, and fourth quadrants, right? So just try to make the closest triangle you can make. For example, if the angle was here, right, this is your angle, The closest triangle can be either this triangle here, or this triangle here, okay? Depending on whichever you like. By convention, what we do is we usually draw down or up. So it's going to be this, it will be your triangle. You can figure out what this angle will be. If you're in the third quadrant, right, again, this will be your triangle. You draw down. If you're in the third quadrant, this is your triangle. Okay? All right, and then you can compare them pretty easily. If you need to change between sine and cos, just use this rule. And that's it for today, guys. Thank you very much for watching. I'll see you guys next time.